Hi everybody. Today we are going to study solution of nonlinear equations. In that, first we consider polynomial of degree n. As f of x is generally denoted as Pn of x, or we for this unity we consider f of x is equal to a0 x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 plus so on up to an minus 1 x plus an. Okay, here degree of x raised to n is largest degree is n and its going on decreasing up to constant. Now here a0 is not equal to 0. If a0 equal to 0, its degree will be not of degree n. So here we have to consider a0 not equal to 0 and other remaining constants belongs to r as a real number. Okay, so if f of x has n roots, it is of degree n, so it should have n roots. Some of them are real and different. Okay, some of them are real and different. That means it should be real numbers and it are different, or real and repeated and the rest imaginary. Here it means that some of, for example, if you consider d minus 1 equal to x minus 1 bracket square equal to 0. Okay, so here x is equal to 1 comma 1 is the solution of the equation. Okay, so here 1 is repeated twice, which means 1 is real number and it is repeated. So here it is the second case will be real and repeated, and rest are imaginary. That means it will be of a complex number. Okay, now geometrically a root of equation 1 is that value of x where the graph y is equal to f of x crosses the x-axis. That means when we are putting the value of x, it should be an intersecting point on x-axis. Okay, so geometrically you can say that the value of or root of this equation is the point which lie on x-axis only. Okay, or which intersect y is equal to f of x crosses the x-axis. Now here there are the conditions for the roots. So for any real number a and b, if f of a and f of b have opposite signs, that means when we are substituting a and b in equation f of x, so if they have opposite signs, then at least one or an odd number of roots of equation f of x is equal to 0 lie between a and b. Okay, that means that the root is in between the values a and b if they have opposite signs. Okay, f of a and f of b. Okay, if f of a and f of b have a same sign, then either no real root or an even number of roots of the equation f of x is equal to 0 lie between a and b. Okay, so when we putting a and b in f of x, if they have the same signs, then there will be no real root. That means it should have a complex root. Okay, or it have an even number of roots. Okay, even number of roots of the equation f of x is equal to 0 lie between a and b. Okay, now next theorem says that every equation of an odd degree has at least one real root, whereas every equation of an even degree, now here for odd degree it has at least one real root, and if remaining will be imaginary, or which we say complex root. Okay, whereas every equation of an even degree, if it is of an even degree polynomial where the last term is negative, has at least two real root. If the last term is negative, so it has at least two real roots and one positive, two real roots in which one is positive and other is negative. Okay, so for even degree there is a condition, it has a positive real root and negative real root where last term is negative. Okay, now we see Descartes' rule of sign. Now consider f of x is equal to x raised to 5 minus 4x square plus 3x minus 5 equal to 0. Okay, now here it is a positive First term is positive, second term is here negative, next here it is again positive, last term is negative. Now here number of sign changes is, here it is first sign change because it is plus, second is negative, next it is negative, and after that it is positive, so here it is next sign change, and here for last it is positive and it is negative. We are considering its coefficient only. Okay, so it is again new sign change. So there are totally 3 sign changes. Okay, 3 sign changes for f of x, okay, which we have given. So if there are 3 sign changes for this equation, which is of an odd degree, so it has 3 positive roots. Therefore this f of x has 3 positive roots. Okay, and remaining you have to check, it will be negative or it will goes toward complex. Now if we consider f of minus x, what will be the equation of f of minus x? We have to replace x by minus x. So here minus x raised to 5 plus minus 4 minus x raised to square plus 3 into minus x minus 5. Here it is constant equal to 0, which means that is f of minus x is equal to minus x raised to 5 means we should be negative, minus x raised to 5. Here minus x square is positive, so minus 4x square. Here minus sign is it is, so it will be negative only. Here 3 into minus x is minus 3x minus 5 equal to 0. Okay, here if we see all terms are negative. All terms are negative, therefore there is no sign change. No sign change. Therefore f of x do not have negative root. Do not have negative root, which means that the remaining root will be an imaginary root. Okay, or you have a complex root. So Descartes' rule of sign is in that first the equation f of x is equal to 0 cannot have more positive roots than f of x has sign change. F of x has changes of sign. Okay, that means in that example 3 sign changes, so it will have only 3 positive root. Okay, it will not consider it will not have a 4 positive roots. It will consider only 3 positive roots only. And similarly for f of minus x is equal to 0, we will do it, cannot have more negative roots than f of minus x has change of negative sign. Okay, that means that if there is a sign change, it will consider, in this example there is no sign change, so it will not have a negative sign. If there was any sign change, it will consider as a root. Okay, negative root, number of negative root. Okay, now we go to the next point. Now Sturm's theorem is, if f of x is a polynomial and ab are any real numbers where a is less than b, the number of real roots of the equation f of x is equal to 0 in closed interval a comma b is equal to the difference between the number of changes of sign in the Sturm's function at x is equal to a and x is equal to b, provided that f of a not equal to 0 and f of b not equal to 0. Okay, this is our Sturm's theorem. Now we go toward our first method, bisection method. Okay, in that first its algorithm is as follow. So in that we have to see, first start, we write the equation of which we have to find the roots with RHS as 0, and then that means f of x is equal to 0, and then denote the function on LHS by f of x. then the given equation is of the form f of x is equal to 0. Suppose that we have to find or come to know that f of a and f of b have opposite signs. Then it means that equation f of x is equal to 0 has a root between a and b. Now here we have to find the values of a and b such that f of a and f of b have opposite signs. Okay, so we have to put in this f of x is equal to 0. Okay, so it will give as our positive or negative. So if it is a positive and negative, then we can say that the root of equation f of x is equal to 0 is in between a and b. Okay, so in step first we take x naught is equal to a plus b upon 2. Okay, we consider here x naught is equal to addition of 2 divided by 2, which means midpoint of the interval ab. Then find f of x naught. Okay, after that if f of x naught is 0, then x naught is the required root between a and b. Okay, if f of x naught is 0, then required root between a and b. If f of x naught is not equal to 0, and then the root is either between a and x naught or between x naught and b. Okay, so here if it is not equal to 0, then it will be positive or negative. Okay, so if it is if we consider here, it will be in a graph. Here if a is positive and x naught is negative, it will be in interval a and x naught. And if it is x naught is positive and b is negative, so it will be in interval x naught and b. Therefore either f of a and f of x naught have opposite sign, or f of x naught and f of b have opposite sign. Okay, so from these two figure you can say that here a and x naught in first it is considered that f of a and f of x naught have opposite sign. Okay, f of a and f of x naught has opposite sign. So here next root will be in interval, which means x1 will be in interval a and x naught, and it will be the center of a and x naught. Okay, and if we consider x naught and b has opposite sign, so it will be in a graph this x naught and b, and next root will be in between x naught and b, and it will be the midpoint of x naught and b. Here it will be x1. Okay, so hereafter we refer this figure till the end step. Okay, from these two figures only we can get next steps. Okay, so out of the interval a x naught, if you consider first graph, it will be interval a x naught, and for second it will be x naught b. We take the interval at the end of which f of x has opposite sign. Okay, and rename it as a1 b1, clearly the root between a1 and b1. Okay, so after that we have to rename this ax naught or x naught b as a1 b1. So next interval will be in between x1 is equal to a1 plus b1 upon 2, and find f of x1. Okay, so here it is x1 which is a1 and represented as b1. Okay, in this also it is represented as, in second interval it as a x naught, it has a a1 and b as a b1. Here it is x naught as a a1. Okay, and it has a b1, so it x1. Okay, midpoint of x naught and b1. Okay, so here if f of x1 is equal to 0, then x1 is a required root. Okay, if f of x1 is 0, if it is not 0, we repeat the process described in step 2, which means this step. Each such repetition or round of the process is called an iteration. Now we are performing the second iteration. Now either f of a1 x1, that means a1 and here it is x1. Now if we consider this it as an interval, a1 x1 has opposite sign, or x1 b1, or here x1 b1 has opposite sign. You have to graph, from that we have to consider any one of them. F of x1 and f of b1 have opposite signs. Out of the interval a1 x1 and x1 b1, we take that interval at the end of which f of x has opposite sign and rename it as a2 b2. Okay, so from these two interval, okay, a1 x1 and x1 b1, which has opposite sign, which we have to from these two interval we have to select an interval such that it has an opposite sign. That means f of a1 x1 has opposite sign, or f of x1 b1 has a opposite sign, and we have to rename it as a2 b2. And after that, in next step, we have to find x2 is equal to a2 plus b2 upon 2. Now here we take x2 is equal to a2 plus b2 upon 2 and find f of x2. Similar condition will be f of x2 is equal to 0, then x2 is a required root. If f of x2 is not equal to 0, we continue the process. Proceeding in this way, from figure 2.1 and figure 2.2, we see that we get a sequence of x0, x1, x2, x3 of values of x which are coming nearer and nearer to the root c of the equation f of x is equal to 0, which lies between a and b. That means if you see the graph here, this is a graph of f of x and it intercepts x-axis at this point. Okay, if you see the points x1, x2, x3, x0, they are getting nearer to this intersecting point of x-axis, okay, of f of x. In this also you can see that x0, x2, x3, x1. So when you see these points, they are getting nearer to the point C, which is intersecting point of x-axis. You know that an f of x is equal to 0 has an root if it intersects the x-axis. So this point is of intersection is a root of this equation f of x. Okay, so we called it as a C. So when we finding these values, we will go nearer to point C, or we will get a point C also in some examples. Okay, so which will be our root of the function f of x is equal to 0. Okay, so this is the procedure for solving the example for a bisection method. Now here is if the root c is irrational, the process will never come to end, because the values x0, x1, x2, x3 up to dot dot are all rational. Even if c is a rational, the process may continuous for many iterations. Okay, so we will not go to the intersecting point, but we go nearer to that point. Okay, if c is an irrational number. Okay, therefore according to the requirement, we decide how much accuracy we need in the value of the root c to be obtained. Suppose that the value xn is very close to the root c and satisfy our need of accuracy, then we stop the process at xn. That means if we have getting the value xn closer to that intersecting point, we will say that it is a near about approximate value, and we will stop the process at that point xn, and we accept xn as the approximate value of that root. Okay, so this is the procedure for finding the bisection method. Okay, so we will see now examples related to this bisection method. Now consider the example. Find the root of the equation x square minus 25 equal to 0 by bisection method. Now in this solution, consider f of x is equal to x square minus 25. Okay, write it as equation number 1. Now we have to first check the value of x such that it will be considered as opposite sign. F of x will be at that point will be considered positive and negative. That means we have to find the value of x such that f of that value will be one positive and other will be negative. So here if you consider, here we take a rough calculation for finding the value for x square minus 25. So here for x is equal to 3, we start from x is equal to 2. F of x is equal to, it is 4 minus 25. 4 minus 25 is minus 21. For x is equal to 3, it implies that f of x is equal to 9 minus 25, which is minus 16. Okay, for x is equal to 4, it is f of x is equal to 16 minus 25, which is minus 9. Okay, it is minus 9 because minus 6 plus 16 minus 25, which is minus 9. For x is equal to 5, it is 0. F of x is equal to 0. Now for x is equal to 6, if you consider f of x is equal to 6, so it is 36 minus 5. F of x is 36 minus 5 is 16. Okay, sorry, 11. 36 minus 25, which is equal to 11. So we have to consider an approximate way. You can select any of interval. If I select as interval, here it is near minus 16, which is less than 0, and here it is 11, which is greater than 0. So here for this example I consider that f of 3 is equal to minus 16 is less than 0, and f of 6 is equal to 11, which is greater than 0. So you can say that f of 3 into f of 6 is less than 0, because here it is negative and it is positive. So product of these two will be negative, so it will be less than 0. Hence root of f of x lies between 3 and 6. Okay, you may also consider 4 and 6 also, but it will give a second iteration only you can get x is equal to 5. Okay, so we have to consider some we have to go nearer to that root, so we will take some longest distance interval. So 3 and 6 will be considered here. Next, it is a iteration, initial iteration, which means first initial approximation. Now here we take x naught is equal to a plus b upon 2. Okay, so here consider a is equal to 3, f of 3 and 6, a is equal to 3 and b is equal to 6. Okay, from these two, here it is a and here it is b. So x naught is equal to a plus b upon 2, which means 3 plus 6 upon 2, which is equal to 9 upon 2, which is 4.5. Okay, so from equation 1 we write it as equation 1, f of 4.5 is equal to 4.5 square. From equation 1 we got 4.5 bracket square minus 25. After solving this we will get minus 4.75, which is not equal to 0. Okay, so here first interval is from 3 to 6, and function value is function's value, f value. Okay, for 3 it is negative and for 6 it is positive. Okay, here we have solved it in above. For 3 it is negative and for 6 it is positive. Now center of this 3 and 6 is 4.5. For 4.5, first interval from 3 to 6. Okay, now here at 4.5 it is negative. 4.5 it is negative. So for iteration first, that means we have to find x1. Okay, we see that we have to consider next interval as one should be negative and other should be positive. So here interval will be start from 4.5 and end with 8 at 6. Okay, you do not consider 3 to 4.5 because both are negative signs. So we have to consider one positive and one negative. So here it is negative and it is positive. So we see that f of 4.5 and f of 6 have opposite sign. Okay, that is f of 4.5 into f of 6 is less than 0. Okay, so root lies in interval in between 4.5 and 6. Okay, so this is our next iteration process. Here 4.5 it is negative and for 6 it is positive value of f. Okay, so here you have to take midpoint of these two. So here it is a1 and it is b1. So x1 is equal to a1 plus b1 upon 2, which gives 4.5 plus 6 upon 2. So it will be 5.25, which means midpoint of 4.5 and 6 is 5.25. Okay, so we have to check the functional value of at 5.25, that is from equation 1. F of 5.25 is equal to 5.25 square minus 25. Okay, after solving, which will gives us, we have to check 5.25 square and we have to subtract it from 25, and it will be 2.5625, which is not equal to 0 and which is greater than 0. Now here it is 5.25, value of f is a positive. Okay, so we have to take an interval from, one should be negative, so it will be 4.5 to 5.25. Okay, so next root will be lie between 4.5 and 5.25. Therefore x1 is not a root. As it is not equal to 0, so it will not be a root. Okay, so iteration 2 will be here f of 5.25 and into f of 4.5 is less than 0. So here we consider next interval is in between 4.25 and 5.25. Here it is negative and here it is positive. So we have to take next midpoint of these two. So here root lies between 4.5 and 5.25. Okay, this satisfies the condition f of 5.25 and f of 4.5 is less than 0. Okay, which have opposite sign. Okay, so here x2 is equal to, which is here you can consider as it as a2 and b2, a2 plus b2 upon 2, which is equal to 4.5 plus 5.25 divided by 2, which is equal to, its calculation will be gives us 4.875. Okay, please see the calculations also. So here it is 4.875. Okay, so here from equation 1 we have, or we get f of 4.875 is equal to 4.875 bracket square minus 25, which is equal to minus 1.234, which is not equal to 0. Therefore it is not equal to 0, therefore x2 is not root. x2 is not a root. So here it is a negative. Okay, so next root will be in between 4.875 and 5.25. Next iteration 3 you can write f of 4.875. f of 4.875 here, it is interval from here to here, 5.25. f of 5.25 have opposite signs, that is f of 4.875 into f of 5.25 is less than 0. Okay, so in root lies between 4.875 and 5.25. Okay, so our next x3 is equal to, now x3 is equal to, consider it as a3 and it as b3. So 4.875 plus 5.25 divided by 2, and its calculation will be 5.0625. Okay, so here we have an interval from, here we have interval from 4.875 to 5.25. 4.875 is negative and 5.25 is positive. So next point will be in between these two. Okay, so here x3 is 5 point, so put in equation 1. From equation 1, f of 5.0625 is equal to, it's 5.0625, we have putting the value of x, okay, minus 25, which will be positive, which is 5.0625 not equal to 0. Okay, so here x3 is not root. Now here x3 is not root because it has a positive, it is near not equal to 0, so it have a positive sign. So next interval will be in between 4.875 to 5.065. So iteration number next, iteration number 4. Here f of 4.875 and f of 5.0625 have opposite sign, that is f of 4.875 into f of 5.0625 is less than 0. So we take x root lies in 4.875 and 5.0625. Therefore now consider x4 is equal to 4.875 plus 5.0625 divided by 2, which is equal to 4.96870, and it's f of x4, that means f of 4.96870 is equal to 4.96870 square minus 25, which is equal to 0.3111, not equal to 0, but it approximately equal to 0. So you can say that x4 is equal to 4.96870 is a root of f of x. Okay, so this is the process for solving the example. Thank you. For today we will see next example in next lecture.